Okay, addition and subtraction of radicals. Just like there are like terms in algebraic expressions, there are like terms in radical expressions. So like terms in algebraic, you could think, what can I do with 3x plus 2y? Nothing. They're different terms, right? One has 3 x's, one has 2 y's. What can I do with 3x plus 2x? I can add them together, right? I have 3 of one thing and I've got another 2 of the same thing, so I have a total of 5 x's. And so we're going to do a similar thing with radicals. So we need to identify like terms. So there's a root 3. Are there any other terms there that are like root 3? What else is like root 3? Is this like root 3? This one? This one? How many root 3s? How many root 3s are there here? How many root 3s are there here? Are they both root 3s?
Yes.
So this one, and 25 root 3. Okay? Okay. Now you got the idea. Root 6. What's like root 6? So we'll put squares around this. Bless you. Okay, root 6. What else is like root 6? Is the cube root of 6 like root 6?
Yeah.
No, why not? One's a square root, one's a cube root. Okay? Is negative root 6 like root 6? And what else? 10 root 6. Are the 3 remaining terms like terms? Yes. So, radicals that have the same, what do we call this? Number, the little 3 there, what's the technical term? Index. Okay, so radicals that have the same index and the same, what do we call the number under the radical sign? Radicand are like radicals and can be added to each other or subtracted from one another. Okay? So, root 6 is like any other root 6 that you see, right? So every time you see, and if you ever get confused in radicals, then just say, just rewrite it, and instead of putting the radical, put an x, right? And just say, I could do x's, right? We're all good at adding and subtracting x's. We may not be as good at adding and subtracting root 6's. So George Polya, Hungarian mathematician, one of his problem-solving methods was to solve a similar problem. So, I don't like radicals, but solve a similar problem. If it had x's, what would I do with it? Okay, I can do stuff with x's. Right? And eventually you should become comfortable with the radicals, and then it's all good. Okay, I have 2 root 6's, and I'm going to subtract from that 10 root 6's, which will give me how many root 6's? So forget this first. Negative 8 root 6's, and then I'm going to add 5 root 6's, and what will I end up with? Negative 3 root 6's. So when these guys are the same, you can ignore the root 6 and just say 2 minus 10 plus 5 is negative 3, and then you say, but wait a sec, it's negative 3 root 6's, right? Like that term. So treat root 6's like you treat x's or apples, right? I have 2 apples and I take away 10 apples and I add 5 apples. Negative root 10 minus root 10 plus 2 root 10 is? Okay, I have negative root 10 and I subtract root 10, so how many root 10's do I have? Negative 2 root 10's, and then I add 2 root 10's. If I have negative 2 of something and I add 2 of the same thing, I don't have anything, right? It's 0. You could write 0 root 10, but that would be kind of silly, right? Because 0 times anything is 0. Okay. Okay, we good? Some radicals need to be simplified first, right? So all the stuff we did yesterday, the changing entire to mixed, could be determined if they're like radicals. You look at root 12 and root 48, and they're not like radicals, right? One's got 12, one's got a 48. But what is root 12? It's 2 root 3. Okay. Now, you might want some detail on that, right? Some of you are just going to be able to look at root 12 and say, oh, that's 2 root 3. And some of you are looking at it going, how the heck did that happen? So you got to think, what did we do, right? Well, we had the perfect squares listed, and we say the root of 12 is the root of 4 times 3, which is root 4 root 3, which is 2 root 3. That's where the 2 root 3 comes from. What's root 48? Go through the same process. What's a perfect square that goes into 48? 16, right? Look, 4 goes into it, but if 4 goes in, always look higher, right? Always look at 16 and then 64. So 48 is 16 times what? 3, which becomes root 16 root 3, which becomes 4 root 3. Okay? Now, I'm going to pause this and let you practice. Okay, so we did all this yesterday. So now you need to make all the rest of them. They all should come up as root 3s. Right? Because it says, show that the following are like radicals. Just like when we say solve by factoring, it will factor. We will not give you a question and say solve by factoring and then sit back and laugh, or it doesn't even factor. Right? We'll give you a question that says algebraically determine, and if you can solve it by factoring, that's usually the best method because it's the fastest, but there are other ways you can solve. You can use quadratic formula, etc. Okay, so I'm going to pause. Okay, so we have 25 root 3, 6 root 3, negative 6. Remember, that's still going to be negative when there's a negative. 4 root 3, 2 root 3. Can we add or subtract unlike radicals? No. Just the same as we can't. So just the same as we can't add 2x plus 3y, right? They are not like terms. Simplify each of the following by simplifying the radicals first and then collecting like radicals. Okay, so what we have is I got a root 5, a root 45, and a root 20. So unlike the first page where we had 3 root 6s plus 2 root 6s or whatever, right? These will perhaps become all like terms. We got to find out, right? So we've got 2 root 5. Nothing you can do with root 5. No perfect squares go into that. Minus 6. Okay, root 45. What's the perfect square that goes into 45? 15 is not a perfect square. It doesn't have a square root. Okay, 4, 9, 16, 25. So 9, right? Okay, 9 times 5. Now, here's a little hint. If that's a root 5, we're probably going to have a 5 in here as well, right? So likely 5 goes into this and 5. So how many times does 5 go into 20? Okay, so this becomes the root of 4 times 5. So the first term is 2 root 5. This is root 9 root 5 plus root 4 root 5. Okay, you don't have to show all this work, right? I'll do it again. We'll do this and then I'll do it again and just say, okay, this is what you really need to show. Okay. So this is 2 root 5 minus 6 times 3 root 5, right, because root 9 is 3, plus another 2 root 5, because root 4 is 2. So that's 2 root 5 minus 18 root 5 plus 2 root 5, which is how many root 5s? Say it. Negative 14. So if you want to do it on your calculator, what are you going to do? You're going to go 2 minus 18 plus 2 equals. Right? Because you know that if I'm adding or subtracting like radicals, I just add or subtract the coefficients. 2 minus 18 plus 2. Enter. And it says negative 14. And then you say negative 14 what? there's negative 14 root 5s. Okay, so it's like root 5s or apples or whatever, right? You just forget that there's any root 5s and just go, I've got 2 minus 18 plus 2. I have negative 14 of these things, which are all the same, right? They're like, so they're all root 5s. Okay, so what do you have to show? Or what could you show? So you could do this, right? So I got 2 root 5 minus 6, and you might say root 45 is 3 root 5. Plus, and you would say that root 20 is 2 root 5. And then you can go to this line, which is the second last line. And then you go to the last line. So you can show as much or as little work when you are converting radicals as you like. Okay? You could do the whole thing, take the 45, break it down to 9 times 5, break it down to root 9 times root 5, break it down to 3 root 5. Okay? It's on 3 lines. Or you can just take root 45 and go 3 root 5. You want to know that say, how do you know root 45? So let's say you look at root 45 and you say, I think it's 3 root 5. How do you know it is? You go into your calculator, you type root 45, enter, you type 3 root 5, enter, and you say they're the same. Good, I got that right. Okay? So if you want to do this in your head, this, I don't want that. If you want to do this in your head, but you also want to check, again, don't do this. But you also want to, I'm not going to do much calculator stuff. So you go root 45, which I think is the same as 3 root 5. Enter. And it can't possibly take you as long as it took me because you have the keys right in front of you, right? You're just punching them. If you get the same answer, then you know the root 45 is 3 root 5. You know you're looking for root 5s because you got a 2 root 5, and I'm looking for like terms, right? And it doesn't take long to check. And then you say, okay, good. And then root 20, and you say, I think that's 2 root 5, root 20, enter, 2 root 5, enter. Yeah, they're the same. Okay? So that's if you want to do it this way. These have to be right, right? If they're wrong, then it's just not good, right? The whole thing becomes wrong. Okay, 2 root 3. That means we're looking for root 3s, but 90 can't be a root 3, right? Because what goes into 90? 3 goes into 90 30 times, and 30 is not a perfect square. Okay, so this might be like x's and y's. Maybe this is an x, and this is a y, and this is an x, and this is a y, or something, right? So we'll have 2 sets of like terms. Okay, so 2 root 3 minus, what perfect square goes into 90? 9, right? 9. So it's 9 times what? 10. What perfect square goes into 40? Your choices are 4, 9, 16, 25. 4. If 4 goes to 16, go into 4? No. So it's 4. 4 times what? 10. Oh, okay, look, I'm going to end up with some root 10s, right? Because I'm going to pull the 9 out and the 4 out. And then 27. Well, if these guys are going to be like, then this is probably a 3. So 27 is 9 times 3, and 9 has a square root. Okay, good. So things are going swimmingly. So we got 2 root 3 minus root 9 root 10 plus root 4 root 10 minus root 9 root 3. Okay. And again, some of you might just go to what I'm now going to write as the next line. Okay? And that's perfectly fine. So some of you may show this, and some of you might go straight to this line. 2 root 3 minus 3 root 10 plus 2 root 10 minus 3 root 3. Okay? So it is acceptable in a solution, determine, show your work, to go from the original question to the line that I just wrote, the last line I just wrote, right? Because you're just saying, okay, look, I know root 90 is 3 root 10. I know root 40 is 2 root 10. I know root 27 is 9 root 3. How do I know that for sure? Because I spent a little bit of time with my calculator and I punched in root 90 and I punched in 3 root 10 and I said, yeah, they're the same. Okay? There's no excuse for getting that wrong. There's zero excuse for writing root 90 as something and getting that incorrect. Because you got a calculator that will verify it for you, and you can do that in approximately 5 seconds. Time yourself. You get a stopwatch going and go root 90 and go 3 root 10. Okay? And if you can't go root 90 to 3 root 10 in your head, then you're going to spend the same amount of time by figuring out, okay, what goes into it and writing it this way and then getting down to here. Okay? And if you're still not sure, you can still check these. Right? So you've got built-in checks that. Okay, how many root 3's do I have? Yeah, 2 minus 3, which is? So I have negative 1 root 3, which we will write as negative root 3, right? We don't put a 1 in front if it's a 1. And how many root 10's do I have? Negative 1 root 10, so we're going to go minus root 10. Okay, so do I end up with minus root 13? Is that my final answer? No, because they're not like terms, right? I can collect the root 3's together, I can collect the root 10's, but in the end it's like I have x minus y, right? They're different terms. Okay, I'm going to pause this. You do the next one. All right, so 24 is 4 times 6, 96 is 6 times 16. I really should have written 16 times 6. And 432 is 144 times 3. You may not have got there in one step, right? So you might have done this. 432 is 36 times 12, and then get root 36 root 12, which is 6 root 12, and then have to go, but 4 goes into this. And this is 2 root 3. And so I get 12 root 3. So there's my 12 root 3. And then this is 4 root 6, and this is minus 24. So I get negative 20 root 6 plus 12 root 3, which could also be written 12 root 3 minus 20 root 6. Okay? So on a multiple choice, you might see this, you might see it this way. Just recognize they're the same. Okay. Questions? So we must change entire radicals to mixed radicals in order to determine whether or not we have like terms. Find the perimeter of the following right triangle and write the answer as an exact value. Notice how that's bolded, exact value. Okay, so if it's a right triangle, this is the right angle. It has to be, right? So we can call this triangle A, B, C, that's little c, little a, little b, and we can say c squared is equal to a squared plus b squared. So c squared is equal to 8 squared plus 4 squared. That's 64 plus 16. So c squared is 80, and c is the square root of 80. Now, we don't have to in this formula. Normally, if I said c squared equals 80, we would have to say c is equal to plus or minus the square root of 80. But since we're dealing with the side length of a triangle, we don't put in the negative. We say c is equal to just the positive or principal square root of 80, right? And that's what the radical sign means, the positive or principal square root. Now, root 80 is what? 4 root 5. Okay, so what's the perimeter? Perimeter of a triangle is the distance around. Expressed as an exact value. That's it, okay? So, you got to hammer this into your head. When we say exact value, you will never write decimals. Okay? Never, ever, ever. You will not get your calculator out to try and say what is 4 times root 5. And then go and say it's, whatever, 14 point, whatever that works out to, or, 17 point something. You do that, I will take off a half mark. Okay? Because you have not followed the instruction, which is answer as an exact value. Don't do it as a, well, you know, it's not an English essay where if you throw enough stuff down, enough something might stick, right? So don't go 12 plus 4 root 5 and then turn it into the decimal. You've gone a step too far. In math parlance, you have shot yourself in the foot. It's like you had the right answer. If you just left it there, it all would have been good. But you decided that you had to just say, I'm not really sure, so I'm going to give you this, but I'm also going to work it out, at which point you lose half mark because you went too far. So exact value will either be a fraction, 1/3, don't change it into 0.3. It could be a fraction like 2/5. It's not a marked losing offense if you were to write 12.5 as an exact value, because that is exact. So any decimal that terminates, you can write as the terminating decimal. So if it was like 11.25, and you could also write that as 41/4, either one would be acceptable. If it's 11 1/3, you could write that as 34/3, but you could not write that as 11.3, right? Unless you put a bar over top, but you're taking some risks. The other thing we need here is centimeters. So we're going to throw that in brackets to say it's that many, what? It's centimeters, right? Because this thing has units with it. So the perimeter is measured in centimeters. Okay? So, generally speaking, when we say exact value, especially in this course, you're probably going to have a radical in there, right? The root of whatever. Quadratic formula, exact value, your answer will look like, 7 plus or minus root 3/2. That's an exact value. Taking it to a decimal from there is not exact. If we want the decimal, then we'll say rounded to the nearest hundredth, or rounded to the nearest tenth, and then you work it out. So if we said the perimeter rounded to the nearest tenth is, then you plug that in your calculator, work it out, round to 1 decimal. If it's a numeric response, we could ask numeric response this way. Probably wouldn't do it for a 12, but we could say the answer is written in the form of AB plus C root D. A, B, C, D, and you write 1, 2, 4. No, throw a radical sign under there. Okay, so that's a possibility. So your answer will be written in the form AB plus C root D, 1, 2, 4, 5. So that could be asked as a numerical response, even though your answer is as an exact value. Okay. That's not, it's more likely if this is a single digit to ask it that way, right? Or you saw stuff that asked you, we could do this. So your answer is written in the form A plus B root C. What is the value of A plus B plus C? Okay, so you saw one of those, right? What's the value of A plus B plus C? We got 16, 21. Right? So just be aware, once you have the answer, maybe it's not in the form you want. Or we could say rounded to the nearest tenth, what's the answer? And then you'll be entering whatever, whatever it is, I don't know. Determine the perimeter of a rectangle with a width of root 108 and a length of 25 root 3. Okay, so I don't know about you, but I find it handy if I'm working off a diagram. Right? So I'm going to draw me a rectangle. I'm going to put down a width of root 108 and a length of 25 root 3, and then I can come up with an expression for perimeter. So what's the perimeter of a rectangle? So you could say it's like 2L plus 2W. Right, you got 2 lengths plus 2 widths. You could write L plus W plus W. You could also just say it's 2 times L plus W. Right? That's kind of the simplest. So here, if I do that, 2 times, so L is 25 root 3 plus root 108. And now I got to start thinking, maybe this root 108 can be simplified and be something root 3.
Oh, 6.
And it's 6 root 3. Okay. At this point, I'm no longer going to show you how root 108 is 6 root 3, right? You got to puzzle that out yourself and figure it out. If you want, you can come up after and say, why is root 108 6 root 3? Okay. It's 36 times 3 and so on, right? But so now we're writing them down. And so what does that work out to? So how many root 3's do I have here? I have 31 of them, right? And then how many? 62. How can you check that? You can go 62 root 3, enter. You can go root 108 plus 25 root 3 plus root 108 plus 25 root 3, right? You just add each side individually and then hit enter. And if they're the same, you know it's right. And this is simplest form. And they didn't put units on there, so there's no units to put here, right? They didn't say root 108 centimeters, they said root 108, so it's just a number. It doesn't have any units with it. So it should technically have units, right? I mean, you can't permit it, it's just a number. If the area of a square is 25 square meters, then the length of each side is 5 meters. If the area of a square is 90 square meters, then the length of each side of the square is? Well, how'd you get a 5 from the 25? Square root. So what are we going to do with the 90? What's square root 90? What's the square root of 90? 3 root 10. Good, right? You're starting to think. Or you remembered from a couple pages ago. Okay. Either way, it doesn't matter, right? Like, eventually you're going to see enough root 8s that when you see root 8, you're just going to think 2 root 2. Right? You won't have to sit there and calculate. You see root 8, you say, that's 2 root 2. Same as if I say, what's 4 times 3? 12. You didn't sit there and think, 4, I got 4, and I got another 4, and that's 8, then, right? 4 times 3 is something you know. Why? Because you've done 4 times 3 so many times, you've looked at flashcards or whatever, you know that it's 12. Eventually, root 8, you'll probably know it's 2 root 2. Why? Because you're going to see it like 15 times in the homework. You get to the point where root 8 is 2 root 2, and you're not thinking about root of 8 is root of 4 times 2, which is root 4 root 2, which is 2 root 2, right? You just go to the answer. A large, medium, and small square are attached to one another as shown in the diagram. The medium square has an area that is 1/4 of the largest square. So how big is it? What's the area of the largest square? 200. The medium square has an area 1/4 of the area of the largest. What is it? 50. You can label that on the diagram, right? All you're doing is using the information provided and say, oh, 1/4 of 200 is 50, right? If you're wondering where does that come from, it's 1/4 of 200 square centimeters. If the total length of the 3 squares is 18 root 2, determine the side length and perimeter of the small square. What's the side length of this square? Just express it as an expression. Come on, man, we just did 2 of these on the other page. It was 25 was 5, 90 was root 90, 200 is root 200. What's the side length of this square? Root 50. The side length of this square, I don't know. We're going to call that x squared. We'll call this x. Okay. We don't know. Unknown, right? Okay. The total length of the 3 squares. So what expression am I going to come up with? Root 200 plus what? This plus this. What's this?
X.
X. What's this? And what's that equal to? 18 root 2. Okay? This is a tough question. We'll give you a variation of this as a bit easier question, right? Like on the test, we said the sum of the squares of 2 odd numbers. Remember in class we did, there were like 3 consecutive odd numbers, and the square of this one was 18 bigger than the sums of the squares. That's tough, right? We gave you easy, 2 odd numbers. What are the 2 odd numbers? X and x plus 2. What were they before? X plus 2, x plus 4. The sum of the squares, x squared plus x plus 2 quantity squared is equal to, and we gave you some sum. right? And you know it's got a factor. Why? Because they're integers, they're numbers. Okay. Root 200 is what? 10 root 2, right? X is x. Root 50 is what? 5 root 2. And that's equal to 18 root 2. So we have x plus 15 root 2 is equal to 18 root 2. So what's x? 3 root 2. Right? Nice, right? All solved. Everything was like terms. They were all root 2's. Right? The only one they gave us was the 18 root 2, but root 200 turned into a root 2. Root 50 turned into a root 2. So the side length, right? We don't need the area of that square, right? Which is, what's the area of the little square? What's the area of the little square? It's a number. It's got no radical. 18, right? 3 root 2 times 3 root 2. Oh, how do we do that? We put the 3 under the radical sign. It becomes a 9. We have the square root of 18, and then we square that. We get 18. But they didn't ask that side length and the perimeter. So what's p equal to? It's a square. 4 times x, right? Which is 4 times 3 root 2. And oh my god, that's tomorrow, multiplying radicals. What's 4 times 3 root 2? 12 root 2's. Units? Centimeters. So the side length is 3 root 2 centimeters. The perimeter is 12 root 2 centimeters. They are exact values. You will always state as exact value unless you are told rounded to the nearest whatever. Done, right?